NASA has just released images of the interstellar object 3I Atlas. And the internet has erupted in controversy. The images look terrible, even though they were taken by one of the most advanced space agencies on Earth. Even amateur astronomers have taken clearer pictures than NASA's multi-million-dollar equipment. But something much more disturbing is going on behind the scenes. Information about this mysterious object is being systematically buried online, and the truth is becoming harder to find. The problem isn't just bad images. It's how modern science media can shape or completely silence opposing views before they're heard. Stay tuned, because what happens next will blow your mind. If you are fascinated by the mystery of 3I Atlas and want to see more amazing cosmic stories, hit that like button and let the universe know you are watching. Every click helps keep the quest for the unknown. A live comment below. And let me know where you are watching this video from. I want to see what corners of the world are witnessing this along with me. On Wednesday, November 19, NASA held a major press conference to present new data on 3I Atlas. They revealed that 15 different space missions were simultaneously tracking the object, including the James Webb Space Telescope, the Mars Reconnaissance Orbiter, the Perseverance rover, and the Lucy asteroid probe. This is an unprecedented level of attention to a single space object. During the press conference, Nikki Fox, Associate Administrator of NASA's Science Mission Directorate, gave a revealing statement. She admitted that NASA had to push many of their scientific instruments far beyond their normal operating limits just to collect data on 3I Atlas. She used the exact phrase, operations beyond normal capabilities. That admission alone is enough to raise questions. Why would NASA need to operate equipment at the edge of its design parameters for what they claim is just a regular comet? The images released by NASA showed a long, blurry trail that disappointed both scientists and the public. Meanwhile, independent observatories and amateur astronomers posted much sharper images online. These clearly showed powerful jets of material shooting toward the sun and a rapidly growing tail structure. The contrast was stunning. People began to question why a space agency with a $20 billion budget couldn't produce images as good as those taken by university telescopes and backyard astronomy enthusiasts. The answer lies in the equipment used. NASA relies heavily on the HiRISE camera on the Mars Reconnaissance Orbiter. HiRISE was specifically designed to take extremely high-resolution images of the Martian surface. It was never built to track fast-moving objects in space. It doesn't support long exposure times. It can't track a fast-moving interstellar traveler. Engineers explain that NASA tried to fix this by stacking multiple short exposure images together to increase brightness. The result is a blurry, lackluster image. Some planetary scientists even say that using HiRISE for this mission was a risky gamble that ultimately failed. But that raises another question. NASA has access to the Hubble Space Telescope and the James Webb Space Telescope, both of which are capable of taking high-resolution images of distant moving objects. Why weren't those instruments prioritized to observe 3I Atlas? Some researchers have proposed redirecting the Juno probe to conduct a close flyby, but engineering assessments have shown that Juno's orbit and energy budget would make that impossible. So NASA had a rare opportunity to study an interstellar object up close, and it let it slip away. That decision is now fueling a fierce debate about the agency's priorities and flexibility when it comes to responding to unprecedented cosmic events. What makes this situation even more controversial is what NASA chose not to say in the press conference. They repeatedly insisted that 3I Atlas is a completely natural comet. They dismissed any speculation about its artificial origin or unusual properties. According to NASA Deputy Administrator Amit Kshatriya, 3I Atlas's brightness, behavior, and tail structure all fit the standard comet model. The only thing special about it is that it came from outside the solar system. However, this blanket conclusion ignores a long list of anomalies that independent researchers have been pointing out for weeks. Avi Loeb, a renowned Harvard astrophysicist, compiled a detailed list of unusual features that didn't fit the natural comet model. One of the most striking was the extremely high carbon dioxide content combined with unusual levels of nickel. NASA briefly mentioned nickel, but explained it with something called the nickel-carbonyl cycle. Here's the thing. The nickel-carbonyl cycle is a chemical process used in industrial settings to refine nickel metal. It has never been observed naturally in space. The only known instances of this process occur in factories smelting nickel-based alloys. NASA provided no natural examples, no previous observations, and no explanation for how this industrial chemistry could occur spontaneously on a comet. Yet this glaring gap was not mentioned once in the entire press conference. Another feature that NASA completely missed was the presence of highly collimated jet structures that extend millions of kilometers toward the sun. These are not the diffuse gas clouds typically seen around comets. They are narrow, spear-like formations that remain stable over days of observation. I analyzed the available data and even consulted AI tools to determine if any natural objects in our solar system have ever exhibited similar behavior. The results were surprising and deeply disappointing. The jets, according to analysis, span between 1 and 3 million kilometers. They are clearly visible in both the superimposed image and the amateur images taken between November 8 and 12. The jets are so well defined and highly collimated that there is no evidence of rotational blur. Some jets point directly at the sun, cutting through the solar wind. This kind of activity at 4 astronomical units from the sun is extremely rare. Conventional cometary jets are streams of gas escaping from vents in the nucleus. However, the structures observed by 3I Atlas looked more like long, straight columns, more like engineered jets than natural outflows. I asked the AI systems to provide examples of comets that produce similar sun-facing jets that stretch millions of kilometers. Initial responses listed several well-known comets, including Comet Hyakutake, Comet Hale-Bopp, and Comet McNaught. But when I looked more closely at these examples, the data was no longer accurate. For example, the so-called reverse tail of Hale-Bopp is actually an optical illusion. It occurs when the Earth crosses the comet's orbital plane, causing large dust particles to appear as if they were heading in the opposite direction. This is a geometric effect, not a real physical jet. When I pointed this out, the AI immediately corrected itself and confirmed that Hale-Bopp's reverse tail was not a real jet. The same problem appears with other examples. Comet Halley was thought to have produced a sunward jet in 1910, but data from the European Space Agency's Giotto spacecraft confirmed that this was also a misunderstanding. Material was actually flowing outwards, not towards the sun. Hyakutake's ion tail is shaped by magnetic fields in the solar wind, but it does not produce the kind of steady narrow jet seen in 3I Atlas. After several calibrations, only 2 comets remain as valid examples. Comet 100 and 3P Hartley 2 and Comet 67, P. Churyumov-Gerasimenko, both of these comets exhibit short-lived sunward jets, but these jets are only a few hundred kilometers long. They are short-lived, and they do not resemble the million-kilometer structures seen in 3I Atlas. The conclusion was clear. No comet in the solar system had ever been recorded to produce collimated jets that extended millions of kilometers toward the sun and withstand the sun's radiation pressure for long periods of time. Yet 3I Atlas did it. This was no small detail. This was a fundamental anomaly that deserves serious scientific attention. Instead, the NASA press conference pretended it didn't exist. As I continued to explain why these misleading examples were being repeated, the AI made a remarkable admission. It explained that many of the natural analogies circulating online come from proponents of the traditional comet model, including prominent astronomers. These experts often cite cases like Hale-Bopp or Halley. Without mentioning important limitations, most anti-tales are optical illusions or very short-lived fluctuations in cometary clouds, not physical streams that persist over millions of kilometers. When these simple examples are widely shared on social media platforms, they create an echo chamber that reinforces the narrative that 3I Atlas is completely normal. AI systems learn from this information flow and automatically accept it as fact, amplifying these claims. Without verifying the underlying science, this is where the problem really gets serious. AI tracked down the source of this misinformation and found that many popular science accounts were spreading these inaccurate comparisons, accounts with names like Astronomy Vibe and For All Curious regularly post similar lists of comets, repeating the erroneous arguments about Hyakutaki's ion tail or Hale-Bopp's jets. These posts often cite arguments from Brian Cox, a renowned physicist and science communicator whose posts on the subject have gone viral and garnered tens of thousands of likes. They provide a credible counterpoint to the sensationalist tabloid headlines about alien probes. The problem is that most of these examples are scientifically inaccurate. Meanwhile, posts from groups focused on anomalies like UAP Watchers and 3I Atlas Anomaly clearly documented these unusual features with careful attention to observational data. However, these posts were quickly overwhelmed by the mass of content that repeated the message that everything was normal. The algorithm prioritized mainstream stories because they appeared more frequently and came from verified accounts with large followings. Opposing views were pushed down in search rankings and social media feeds, becoming virtually invisible to most people searching for information about 3I Atlas. This filtering effect is not accidental. It reflects a structural problem in the way modern science communicates with the public. The principle that extraordinary claims require extraordinary evidence is a cornerstone of scientific thinking, but in practice, it has been transformed into something else. Extraordinary claims now require extraordinary consensus. Ideas that challenge the prevailing paradigm must pass through a system of censorship designed to protect established models. Hypotheses of artificial origins or unnatural phenomena encounter barriers at every stage. They are difficult to publish in peer-reviewed journals. They are excluded from mainstream scientific media. They are labeled as extremist or speculative, even when they are based on valid observational data. A search conducted on November 20, 2025, found no peer-reviewed journals that had published a serious paper that considered the possibility that 3I Atlas was artificial in origin. Avi Loeb submitted a manuscript to Archive in July 2025, questioning whether 3I Atlas could be extraterrestrial technology. That paper was not peer-reviewed for months. Meanwhile, natural comet models, while leaving many features unexplained, were accepted and disseminated rapidly. The control mechanisms of academic publishing ensure that only conventional explanations are taken seriously. Alternative theories are relegated to the margins, where they exist in blog posts, online forums, and YouTube videos. This exclusion from mainstream discourse inadvertently creates an environment that breeds sensationalism and hype. Serious scientific questions are mixed with wild speculation. Because there is no official channel for serious debate, this creates an irrational, vicious cycle. AI systems scan the internet for credible information. They find only natural explanations appearing in peer-reviewed journals and reputable scientific outlets. They conclude that these explanations are probably correct. They then amplify these views while filtering out alternative hypotheses. The result is a self-reinforcing cycle in which a single view dominates the information ecosystem, regardless of whether it fully explains the observed data. The situation is made worse by the pressures of expertise within the scientific community. Many astronomers are reluctant to explore unconventional ideas because doing so can lead to professional isolation. Avi Loeb had a reputation and a long career at Harvard that allowed him to question existing models without losing his credibility. Most researchers do not have that luxury. Without an established reputation, any scientist who seriously explores the possibility of artificial origins risks being labeled as incompetent or unserious. Their papers may be rejected. Their funding may dry up. Their peers may shun them. This creates a chilling effect, discouraging curiosity and stifling innovation. The history of science is full of examples of ideas that were initially dismissed as untenable, but later proven correct. Continental drift was ridiculed for decades before plate tectonics became the foundation of modern geology. The idea of an expanding universe was considered absurd until observational evidence proved it was irrefutable. Inflationary cosmology faced fierce opposition before it became a standard part of the Big Bang model. Scientific progress occurs when old assumptions are challenged, but a system that is too rigid will cause new ideas to die before they can be properly tested. What happened with 3I Atlas is a case study in how information control works in the digital age. NASA held a press conference and delivered a clear message. 3I Atlas is a natural comet. There is nothing unusual about it. The media repeated this message. Science communicators with large platforms amplified it. AI systems learned from this repetition and began filtering out conflicting information. Within days, the dominant narrative was established. Anyone searching for information about 3I Atlas would see pages and pages of articles explaining that it was just a comet. Anomalies noted by independent researchers became increasingly difficult to find. This is not a conspiracy. It is a system that works as designed. Scientists favor caution and consensus. Media favor clear, simple stories. AI systems favor information that is repeated frequently from reliable sources. All of these incentives are designed to suppress opposing views. Even if those views are based on established observations, the result is a carefully filtered version of the story. Complexity and unanswered questions are smoothed over. Controversy is dismissed. Mystery is reduced to a familiar, thought-free explanation, but the anomalies are still there. The highly collimated jets are still there. The nickel carbonyl chemistry is still there. The unusual brightness fluctuations are still there. The lack of a clear natural precedent is still there. These features don't disappear. Just because NASA says they fit the Comet model, they need to be studied. They deserve serious scientific attention. Instead, they're buried under a series of oversimplified explanations and false analogies. The question is not whether 3I Atlas is artificial. The question is whether we are willing to study that possibility with the same rigor as we apply to natural hypotheses at present. The answer seems to be no. The system is designed to reject extraordinary claims before they are even scrutinized. It is a failure of science, not because the conclusions are wrong, but because the process is biased from the start. The internet is vast, but at least there are hundreds of thousands of people willing to listen to differing views. That's the only reason this story has survived outside the mainstream. Independent researchers, amateur astronomers, and curious individuals are keeping these questions alive. They're documenting the anomalies. They're challenging oversimplified narratives. They're refusing to accept that 3I Atlas is just another comet when the evidence suggests otherwise. The point is not to believe in alien probes or to reject the scientific consensus. The point is to maintain intellectual honesty in the face of institutional pressure. The point is to acknowledge that science advances by questioning assumptions, not by defending them at all costs. The point is to acknowledge that sometimes the most important discoveries come from ideas that make us uncomfortable. The images NASA releases may look terrible, but the real problem isn't the quality of the images. The real problem is what they represent. They represent a missed opportunity. They represent a reluctance to explore the unknown. They represent a system that prioritizes control over curiosity, and most worryingly, they represent a future where information is so carefully filtered that it's nearly impossible to find the truth. 3I Atlas, still moving through space. The questions surrounding it will not go away. The anomalies will remain unexplained, and the people asking those questions will not stop, just because the mainstream narrative tells them to. The spirit of exploration and thinking outside the box has always been the driving force behind science. It is alive in the researchers who refuse to accept easy answers. It is alive in the observers who continue to document what they see. And it is alive in all those who watch these videos and ask the questions others are afraid to ask. The truth about 3I Atlas may be buried online, but it's not lost. It's waiting for those brave enough to dig it up. Thank you for following this content. See you again in the next analysis, where the spirit of exploration and thinking beyond the limits is always the driving force to push science forward